All right, block one, here's a chance to look at the review, the test review, and here's a key that works through it. One by one, I'm just going to go through. These actually in red there are the answers, so if you want to just look at the answers and fast forward to the section that gives you the solution. So, down in number 5, the solution for x is 33, and in red here you see the different triangles. I'm going to talk through them, but you're always welcome to fast forward and just look for the answers. The first one, obtuse. If I back up just a tad bit, let me go back to that one real fast. Obtuse is that red one there, any triangle with one angle greater than 90 degrees, so JLM, and I highlighted it for you to see it visually. The next one is an equilateral, or an acute triangle. The only acute triangle we have is the equilateral triangle, and interestingly enough. So if you look at it, it's going to answer the next two are the same triangle. The acute one, that means all your angles are less than 90 degrees, and so equilateral and the acute triangle are one and the same, JKL. That can happen. Isosceles, the one triangle we have in there with two congruent sides, is that obtuse triangle. And finally, number 5, the setup for this equation, we did this in class, but when you have 3 angles of a triangle, the first thing you want to think is, add them all up to 180. So take each of those and you separately add them up with plus signs between them, set it equal to 180. Those are the 3 angles I highlighted there. Now I'm going to actually look for like terms. X's make 6x. Numbers -3 and -15 or -18. Add 18 to both sides. On from there, we want to divide by 6 eventually and get x equals 33. Make sure that's the question being asked, and we are off and running. Next, we want to take and just make sure I mark the divide by 6's in there. Number 6, same idea we want to start with. We want to get that third angle. We know they all add to 180. The two that we have, 78 and 54, add to 132, which leaves us only 48 degrees for that next angle. So I'm going to label 48 degrees in there where the angle that I'm missing, so that acute angle inside. And off to the side I'm kind of marking that 48 degree angle too to kind of clarify. Now we need to know the outside angle, which would be whatever you need to get to 180, which is actually 132 degrees. 48 needs 132 more to get to 180. Well, that's also, we've got it marked as 12x in our picture. So what we're going to do is set that 12x equal to 132. We know that outside angle is 132. So say 12x equals 132. Divide both sides by 12. X is 11, and that's all we needed. Number 7 is really flexible. That's an equilateral triangle. All sides are equal. That means any two pair you set equal. So let's say 5x minus 10 and 15. Set them equal. Solve, you'd get 5. If you do any two other sides, like the bottom two, 15 and 3x, set those equal. Solve, and you get 5. I'm sorry I didn't show the solving on the top pair. Hey. Either way you look at it, you're going to get x equals 5. We can do the other combination of two sides, set them equal, and we get, imagine that, 5. So it doesn't matter which pair, you just need to set two sides equal, solve for x, and move on. Now we're on to number 8. This is find the missing side, and it's a right triangle, so we know that the Pythagorean theorem works. We know that the long side squared is equal to the sum of the two short sides squared. So I showed here, squaring the two short sides, doing a little bit of work. 296 is c squared, and the last thing you do is take the square root to find the actual c instead of c squared, and that's 296 square root of that. There's your answer up above. 9 and 10 are distance formula, so if you haven't done that in a while, here's the distance formula. The first parentheses under the square root is subtracting the x's. The second is subtracting the y's, so it's important that you be able to subtract the x's, subtract the y's. And what you'll end up doing is squaring that result, and it doesn't matter what order you subtract, because one way you'll get positive 6 for x's, say, the next you get negative 6. Both of them, when you square them, you get the same result. You still get 36 plus 64 under the square root. So the square root of 100, and the square root of 100 is 10. So we'll do another one there. Subtract your x's first, then your y's, square the result, add those two together, take the square root at the end, and you're home free. 4 squared root of 20 is about 4.5. Okay, on to 7. I'm going to, since I have in this picture, in this window, I can see 17, 19, 18, and 20. I'm just going to go ahead and tackle those. Are the side lengths what constitutes a triangle? Can you make a triangle out of those? Are those linguini pieces that will make a triangle? In 17, 5 and 8, if you add them together, do not add up to enough. They wouldn't make a triangle because those two pieces wouldn't meet if you folded them down in a triangle. So any two sides have to add to something greater than the third side. So 17 is a no. You can see that 19 is a no. 7 and 7. If the two sides, any two sides add to the same amount as the third side, that triangle wouldn't pop up, it'd lay flat. So the two 7 pieces would be the same length as the 14 length piece. They wouldn't make a triangle because they'd have to lay side by side. So, and then the other two, 18 and 20, both, any pairs you pick, any two sides you pick, add up to something bigger than the third side. So all is well in that problem. Okay, so on to the next page. Here, let's look at 12 now, back up to the top. This is if I want to find out if it's acute, right, or obtuse. This is where you look at squared sides and their relationship. So long side squared compared to the sum of the short side squared. In this case, here's the results of our squaring. 169 for 13 squared is bigger than the sum of the other two squareds. And when that relationship occurs, as long as you're putting the long side first and squaring that, that means obtuse. Number 13, long side 20 squared compared to the other side squared and added. 400 beats 340, so that is another greater than. We have obtuse. Then down to 14 down below, this is about the median stuff. Now, if you're ever given the whole median, and again, 3 medians meet at a centroid, so D is a centroid, and that's the key. If you see the word centroid, you know you're talking about medians that are meeting together. And what happens is the short part is half the length of the long part. That means we take the third of the whole length. That gives us 1 part for the short and 2 parts for the long. So 11 on the bottom for ED, the short part, and 11 plus 11 for the long part DC. That means we have, of course, 22 and 11 for the respective lengths. Okay, moving on to 15. And in 15, this is named the sides longest to shortest, and the angles are pointing basically at the longest side. So if you remember, the longest angle is across from the longest side. Shortest angle is, or smallest angle, across from the shortest side. So I've marked those two. 71 points, the biggest angle, points to AC, the longest side. 48 points to AB, the shortest side, and that leaves the other in between. BC is between those two. 16 down below, filling in those angles. Okay, so to find those missing angles, the first thing, look for isosceles triangles. They really are the key. There's a 31-degree base angle there. You notice the 2 congruent markings, so that angle 2 is also 31. And then with that knowledge, 2 31s make 62. That means I need to do 180 minus 62 to find angle 1. That'll give us a nice total of 118. So those are those 2 and 1. Now angle 3 is just a matter of knowing that that's a 90-degree angle and a 44-degree angle, which is 134. And from 180 to 134 is a distance 46 degrees. So angle 3 has to be 46 degrees. There you go. Email with questions. See you soon.